Now we will see some indifference identities for sine and cosine function, for tangent function, and the double angle identities. Now let's check the sum and difference identities for sine and cosine functions. So these identities are a little complicated. Not complicated, they're easy to remember. Uh, and they are in certain forms. Sine x plus y is equal to sine x cosine y. So you see the pattern here, like sine cosine and sine cosine. So you have to keep this in your mind. And one other thing is plus will be plus in sine. Now sine x minus y, we have minus here and we have minus here. And the pattern is again sine cosine. So it starts xy and then it goes like yx. So these are the important things you have to know. I mean, you have to memorize it. And is it easy to get them from the unit circle? I mean, you can obtain these from the unit circle, but it's not trivial. So it's not directly seen. So it will take time to show them to you. So we skip that part. The only thing why I want to emphasize it, you have to memorize them. And the other thing here is we have a similar one for cosine, but you know there are definitely big differences between two formulas here for cosine and sine. And cosine, it's if it is plus here, use right here negative. It's one difference. And as if it is minus, this will be plus. So we use opposite signs. And the pattern for cos is cos cos sine sine. So this cos cos sine sine. You say xy xy or yx. It doesn't matter because they are sine cos cos sine sine. So you have to use this. Use them. Okay, let's do this example. Okay, let's do this example. Now we want to use a sum identity to evaluate sine 150 exactly without using a calculator. So you know, the old way we use is using the reference angle. So this is what we do. If you remember, 150 here, that's 30 degrees here. This is the reference angle. And this is equal to an S is plus. Sine is plus here in the second quadrant. So we say plus sine 30 degrees. Then you end up with 1 over 2. We don't want to do it this way. We just want to use sum identity, you know. Sum means, okay, we want to write this one as some angle plus some angle. So the best choices will be like 90 degrees and 60 degrees. And we can use the formula for this. It will be, okay, now I want to remind you the formula here. The formula is sine x plus y. And you know, if it is sine, it will be sine cosine, sine cosine. This is x, y, and this is x, y, and yx. So be careful here. And the other thing is plus. Here it's plus. Now x will be 90 degrees. Y will be 60. Now y will be 60, and then x will be 90. What is sine 90? So if you want to get sine 90, I mean, I'm using the unit circle. As you know, this is 1, 0, and this is 0, 1, and this is minus 1, 0. This is 0, minus 1. Now this one equal to, it's 90 degrees, so our theta now is 90 degrees. So you say it's equal to cosine 90 degrees, sine 90 degrees, and the first one here is 0. This corresponds to sine cosine 90, and this is corresponding to sine 90. So now you can put here 1, and cosine 90 is 0. So if there's 0, you no need to calculate this. And this cosine 60 by using this triangle here. You'll get this. cosine 60 is Mujawir divided by Watar. So it's 1/2. So we got 1/2. It's 1/2. Now let's do the try and check. Here it says use difference identity fark. This means fark identity to evaluate cosine 14. Now here, how can we use it? Like, okay, I can use 45, 30 degrees, or I can use 60 minus 45. These angles, we know them. We know their values, so we can use them. So let's remember this. Cosine, it has to be cos, sine. And it will be 45, 30, and 45, 30. And this is minus, so it has to be plus. So this has to be square root 2/2. Cosine 30 is sine 60, which is square root 3/2. And this is square root 2/2 because this is sine 45. And this is 1/2. And when you do this calculation, you will end up square root 6. This one's square root 6. And plus square root 2 divided by 4. So this gives you the exact value of cosine 15. Now let's do another example. Look at here these examples. We can apply the sum formulas here and get new identities. So for example, what is this equal to for all x? So we can use some identity here. So this is x, this is y now, and you know sine cos, and you say x 30 and then 30x, and this is plus here and this is plus. So when you replace these values with their exact values, sine 30 is square root 3/2, and sine 30 is like 1/2. And when you combine them, it will be square root 3 sine x over 2 plus cosine x over 2. And when you put them together, because we have same denominator, so we can put them together, and we get this identity. So this is equal to this one indeed. Now let's look at the other one, the second one. We use, of course, we use the difference formula for cosine. And here, this is cosine, and this is sine, and this is minus, this is plus. Okay, this is the main difference here. Cos, sine, in cos. But here sine, it's sine, cos. This is minus, this is plus. So we put this cosine, and this is pi over 2. It will be cosine 90. We know cosine 90 is 0, and the sine 90 is 1. So now it will be 0 here. This will be sine x. So we got some identity now. For any x this is true, then this is cosine x minus pi over 2 is equal to sine x. Now let's do this try and check and see the new identities. So you can directly use the formula here, sine theta cosine pi, and minus sine pi cosine theta. And this is cosine pi is what? Cosine pi is minus 1, 0. So cosine pi has to be the first one here, minus 1. So you say this is equal to minus sine theta, because this is minus 1, you see. And now sine pi is 0. So you can see this is sine pi, sine 180 degrees. So it's 0. And this one is cosine 180 degrees. So you see it's one of them is 0 and one of them is minus 1. So you will end up with 0 here. So it will be, this one will be sine theta, negative sine theta. Now let's do it here. Cosine theta minus 60 is by using this difference formula, cosine theta times cosine 60. Now plus, minus will make plus, and then sine theta will be sine 60. Now if you put them together, it will be cosine theta. This is 1 over 2, and then this is square root 3 over 2. Then when you put them together, because we have the same denominators, we can write them in the same fraction. So it will be square root 3 sine theta divided by 2. Now sometimes we have some questions like this. We give the expansion of some difference or some sum. So look at here. So write each of the following as a single cosine expression. So is it clear? This expansion is for what? We use cosine, cosine, and this is sine, sine, and here is our x, and this is y, and this is minus. So does it ring a bell? Do you remember anything like it? It looks like it's the expansion of cosine x plus y, right? So using this formula here, look, this thing here, okay. So now this cosine x, cosine y here, x is what? 2 theta, and sine is, y is 3 theta. So you put them together, this will be equal to cosine 3 theta plus 2 theta. So I'm trying to go back to here this time, okay? So this will be then cosine 5 theta. Now when you look at here, this is sine, sine, cosine, cosine, but you can write this one as also cosine 4 theta, cosine theta, sine 4 theta, sine theta. So you can write it this way, like you can switch them because there's addition here. So then you will have this, and this is indeed an expansion for minus, right? This sum for the difference, because this is plus, there's this cosine, cosine, sine, sine. This is for cosine. And this difference formula, the x is 4 theta and y is theta, so it will be cosine 3 theta. Now let's look at here. And what is this equal to in terms of cosine? So definitely it will be 2 theta minus, this is plus, and the cos, sine, sine, and 2 theta, 2 theta, 3 theta, 3 theta. It has to be the expansion of cosine 2 theta minus 3 theta. This is equal to cosine minus theta. And since cosine is an even function, you can directly say this is also cosine theta. Now let's look at this example. X and Y are given. Okay, two angles in standard position with terminal side in quadrant 2. So we can write here, this is given, x, y in quadrant 2. These are the angles. And sine x is given to us. If sine x is equal to 3 over 5, and cosine y equal to negative 5 over 13, it's asking sine x minus y. So, okay, this is the question here. Now, it's better first you write what is given and what is asked. Now, we have to make a relation between sine x minus y and these, and we know a relation between them. It's the sine x minus y formula, and this formula says it's equal to sine x cosine y. You know, if it's a sine function, the difference formula goes with difference, and it will be sine cosine. Sine x cosine y, and then sine y cosine x. And then, okay, what is given to us? It's sine x is given to us, so we can substitute here 3 over 5. And cosine y is given to us, which is negative 5 over 13. Now, what about sine y? Okay, this is still a question mark, and this is a question mark because they're not given here. So what should we do here is to find these two. So how can we find them? So to find sine y, okay, to find sine y, we can use this information. Y is in quadrant 2, and cosine y is equal to negative 5 over 13. Okay, let's use this information. So what's the relation between cosine and sine y? So we use, okay, we can use other methods, but I prefer now identities. Now it's equal to 1. We know this is the most basic identity we have. And here, okay, cosine y is negative 5 over 13 squared. Okay, take the square, and then sine squared y is this. And by, okay, after you do some calculation, you can get like this is 169 and this is 144 divided by 169, and you will end up with sine y is equal to plus or minus 12 over 13. But here we know y in quadrant 2, which says sine is all STC, you know, STC. So STC means like here sine in quadrant 2 is positive. So we say sine is positive here. If sine is positive, so we only take sine y equal to plus 12 over 13. So I wouldn't say that, okay, this maybe this writing is not good here. So you can say this or this. Okay, it should take, but it should take one of the values, not both values. So we say since its sign is positive, so we take the positive value. Now we can put it here. Sine y is 12 over 13. Now when it comes to finding cosine x, we can repeat these steps here. So it will be, what is given to us about x? We have sine x equal to 3 over 5. And this is given, right? This is given here. And now we can use the identities again. I mean, the basic identity, sine squared plus cosine squared. And we will do the same thing here. So we do the same thing, almost the same thing for x now. And sine x is given 3 over 5 squared plus cosine squared x equal to 1. And then after you calculate this, I mean, send this one to the other side, you know, this one to the other side, and you will calculate this as 16 over 25, and this says cosine x is either plus 4 over 20, plus 4 over 5, or cosine x is equal to minus 4 over 5. Now in Q2, the only trigonometric function which is positive is sine, so cosine is negative in 2. So we don't take this one, so we will take only negative value, which is minus, okay, negative 4 over 5. And then now we substitute it in the formula, we get the answer. So these are the steps we should do here. So you have to put the pieces together and solve the question. First, you set up sine x minus y, and then you use the identities for x and y, sine x and cosine y, and you get the result, which says it's 33 over 65. Okay, then, okay, let's see the slides. I mean, what is written here, it should be the same because I don't see any other way of doing this. So we have to use the formula first and then find the trigonometric values by using the identities. So here it goes. Okay, it's a little long, so okay, we got this one. Now try and check exercise. X and y are two angles in standard position with the terminal side in Q1. So the good thing is, like, if x and y's are Q1, so they're all positive. So like sine x, cosine y, they're all positive. That's good. So no need to worry about this minus k's now. And we want to find the value of sine x plus y. First, we write the formula, and by using these, we want to get the values. And sine x here, if you use the sine squared plus cosine squared issue, you will end up with, okay guys, I mean, I will show you, substitute this here, and I will tell you the solution here, because this is positive also, that will be plus. After a quick calculation, you can get square root 3 over 2. And here, after a quick calculation, you will get cosine y is equal to 1 over square root 2. And you can put all in one. Square root 3 over 2 times cosine y, which is 1 over square root 2, plus sine y 1 over square root 2, and then times cosine x. Okay. This has to be x, sorry guys. And the cosine x is 1 over 2. And okay, we end up with this type of answer here. Square root 3 plus 1 over 2 square root 2. Or if you want to rationalize the denominator, you multiply everything with square root 2, both in the numerator and the denominator. So in the denominator you will have 4. Just, multiply the square root 2, you'll get this. Okay, check out the calculations, please. I mean, you should be able to do it by yourself. I mean, by following the method here. The good thing here is we have Q1 and quadrant 1. It makes everything positive, so you don't take any negative value here. Now, we have some indifference identities for tangent function also. So these here, tangent x plus y is equal to tangent x plus y divided by 1 minus tangent x times tangent y. And tangent x minus y is equal to tangent x minus tangent y divided by 1 plus tangent x times tangent y. So as you see here, I mean, they look almost same, but the difference here is if it is positive here, it will be positive in the numerator, and if it is negative, then it will be negative in the numerator. Okay, and then this one, the sign in the denominator, it will be opposite. So okay, you have to memorize it. The derivation of this, like how to get these formulas, not very complicated, but it requires some detailed work. So for this reason, please skip it. But you have to memorize this. Okay. Now, write the following expression as an expression involving trigonometric functions of x. Let's remember, okay, you have to remember the formula for it. So let me remind you, okay, I think it's written here, so I will not write it myself. Okay, now, okay, let me remind you this one, x plus y is equal to tangent x plus y divided by 1 minus tangent x times tangent y. You know, until you memorize the things here, you can make a formula sheet for yourself and then check out the formulas quickly, so it will make you memorize it better. You know, in the questions you can use the sheet, and we will not allow the sheet during the exam. But you know, when you're studying yourself, yeah, you can make a sheet of the formulas, and you can check the formulas from there quickly until you memorize. So here x 45, y is 45, so you put them in the formula here, you know, and tangent 45 degrees is 1, so it's 1 here also, so you will end up with 1 plus tangent x divided by 1 minus tangent x. And here for the cotangent we don't have a formula. The only thing you can see is, I mean, you can use the identity here, this 1 over tangent, you know, cotangent theta is 1 over tangent theta, we already know that, and we can use it here. This will be our theta, and now it will be same here, and we can use the formula for this one. The formula is almost same as this, but here we have to use minus, and now it becomes plus here, and then we use it here, you know, in the denominator, and we get tangent pi over 3 minus tangent x divided by 1 plus tangent pi over 3 times tangent x. And what is tangent pi over 3? Tangent pi over 3 is, you know, it's 60 degrees. It will be square root 3, but if you don't remember, I always do 1, 2, 3, 1, 2 square root 3 triangle. So it's 30, 60, and now 30 always 1, 60 square root 3, and 2 is the biggest angle, I mean biggest side, so 2. So tangent 60 means opposite side divided by the hypotenuse. No, not the hypotenuse, the adjacent side. So you can say from here square root 3 over 1, which is square root 3, and you can put it here, and then substitute. You will get this. Here, don't try to do such thing. Okay, this is definitely wrong, because we have a minus here. If there's a minus, we cannot do it. And also, there's a plus here. There's addition. So if there's addition here, and you know, addition or subtraction, in this case, you cannot do the simplification this way. No, you have to have something, maybe plus something times something plus minus, or I don't know, if they're same, then you can do. Okay, it has to be in multiplication. Okay, this is how we do it. Okay, let's do the try and check examples here. I mean exercises. It says, okay, find in terms of tangent theta. Let's write them. Tangent theta minus tangent pi divided by 1 plus tangent theta times tangent pi. So what is tangent pi? Okay, tangent pi is what? Tangent pi is tangent 180 degrees, so I will check out this here. Check this out. It will be minus 1, 0. This is cosine pi, and this is sine pi. And what is tangent pi? Tangent pi, by using the identity here, that's sine pi divided by cosine pi, which is 0 over minus 1, which is 0. So you can directly say, hey, this is 0, and this is also 0, and when you do this job, you will get this is tangent theta times 0, it will be tangent theta. So you will end up with, okay, I'm writing this answer here, it will be tangent theta over 1, which is tangent theta. This is also clear from the period, you know, also you remember it, also it is clear, also it is clear from the period, because you can subtract um, the period of the function and it will give you the same value. Okay, the tangent theta minus pi is equal to tangent theta, so you're just subtracting pi. This is the period of tangent. It is also clear. I mean, if you know these shortcuts, if you remember them, you can directly go ahead and say, hey, this is tangent theta because this is period. Or add pi here, so you will get, okay, adding pi will give you another angle, but it will be the same tangent. Okay, so you can use also the period here. Okay, let's come to the other question here. It's almost like same as this one, so we will follow the same steps. I am not sure what we will get here, but it will be here instead of pi over 2, instead of pi over 2. I mean, I'm going quick, so you can follow these steps here with pi over 4, and you will have here like 1, so I'm using this now, 1 plus tangent 45 pi over 4 tangent x divided by tangent pi over 4 minus tangent x. This is 1 big tangent. Pi over 4 is tangent 45. You know, tangent 45 is 1. And then this is 1. So we end up with what? We end up with 1 plus tangent x divided by 1 minus tangent x. If there's addition here, you know, or subtraction anyway, you don't do, I mean, you don't do the simplification here unless they are multiple of each other, and these two things are not same and they're not multiple of each other. So we just leave the answer this way. Do not do any simplification. Some students are doing, you know, some simplification. This is wrong. Now, what was the double angle identities? These identities are easy to derive. So you can, okay, here these identities are coming from the sum identities, you know, it's x plus x. You can say here sine x plus sine x cosine x, and it gives you this one. So if you cannot remember it, you can apply the sum formula and you will get the formula for the double identity. Now, for cosine, we have the same thing, like cosine x plus x, which is 2x indeed, and it will be cosine x times cosine x minus sine x times sine x. So it will give you cosine squared minus x, cosine squared x minus sine squared x. And for this one, we have the same thing. I mean, you can write this one as x plus x and use the sum rule for tangent. So it will give you 2 tangent x divided by 1 minus tangent squared x. So this is what we have here. So if you cannot remember those double angle identities, you can apply the sum rules for x plus x, then you can get the identities. Now, let's use double angle identity for cosine to find the cosine 2x here in this question. So in this question, it says sine x is equal to 3 over 4. Find cosine 2x. Now, for cosine 2x, we have to remember the rule. Remember the formula. The formula is, we know it will be cosine squared. You know the rule, the cosine squared, cosine 2x is cosine squared x minus sine squared x. Now, what is sine x? Sine x is 3 over 4, and we can directly write it here. And what about this? So we can use the identity, the basic identity, cosine squared plus sine squared equal to 1 to get cosine squared. So you can put this here, you can substitute here 3 over 4 squared will be, cosine squared x plus 3 over 4 squared will be equal to 1. The cosine squared x equal to 1 minus 9 over 16, and this will make you 7 over 16. Now we can put this here because we need just cosine squared, so we don't need to take the square root and try to find the cosine. And if we try it, we will end up with plus or minus the issue, and it's not given here in the problem. So, but for cosine squared x, it's okay. We already found it. It will be 7 over 16 minus 9 over 16, and this will give you negative 2 over 16, which is, after some simplification, you will get minus 1 over 8. And let's see how it is, how it goes in the slide. As I told you, now in the try and check, we will do the same thing exactly. I leave it to you, but I want to tell you the answer here is if you follow. Okay, here I want to tell you this. Instead of cosine, okay, here it uses cosine squared x plus sine squared x in the following way. So first it says, it says cosine squared x indeed is equal to 1 minus sine squared x. And I can write in terms of cosine squared x, I can write 1 minus sine squared x, and it will give you 1 minus 2 sine squared x. So now I wrote, here he writes cosine 2x in terms of sine x only. So the sine x is given here, so you can put the sine x, substitute, and you can get this answer. And here with this is a formula also for cosine 2x. This is another formula, and you can use the same logic here, and you can directly say cosine 2x is equal to 1 minus 2 sine squared x, and 1 minus 2 times 4 over 5 squared. So if you calculate this one, it will be, okay, it will be 32 and minus 7 over 25, I guess. So it has to be, okay, you can check this, check this. Now let's look at this example. Let x be an angle in standard position with terminal side in Q4. That will be in Q4, the quadrant 4. And the cosine x is given to us. Cosine x is given as 1 over 3. And it's asking what is sine 2x. What is this? Now, in order to find sine 2x, we have to apply the formula. The formula says sine 2x is equal to 2 times sine x times cosine x. So if you don't remember it, like, you can use the sum formula like x plus x, and then you will get the same thing. Now let's apply the formula. When we apply the formula, we will end up with 2 times sine x. So this is the problem. We don't know that one. And now cosine x is 1 over 3. So the question here is to find sine x. So can we use this here and get sine x? Okay, in order to do it, let's set up the relation between sine x and cosine x. This is the fundamental relation, the most basic one. Cosine squared plus sine squared is equal to 1. So cosine x is 1 over 3 squared, and then sine squared is, then sine squared is equal to 1 minus 1 over 9. And now here we have sine x equal to plus or minus square root 8 over 3. Okay, you can take the square and see, okay? And here, what makes the plus or minus? which one? X is in quadrant 4. In quadrant 4, by all STC, all STC, see cosine is positive here. The cosine is the only positive, so sine will be negative here. So we say sine x is negative. Because of this, sine x is negative, so we will take this one. Now we can substitute this in here in the formula. Then it will give you square root of 8. It's minus square root of 8 over 3. This will be negative 2 square root of 8 over 9. Or if you go further and try to simplify this, you will get it's minus 4 square root 2 divided by 9. Check this one, please. Now, if you know the identities and the quadrant of the angle, you don't have to go back to the reference angle and the other stuff. You just use the identities and the quadrant, only the quadrant, to specify it as plus or minus. Now, here is what I got. Now, let's look at the try and check here. This time it gives you sine 2x, sine x, and it's asking this is quadrant 2 and this is sine 2x. Okay, we will use the same thing, but here sine x is given here, it's 2 over 3 is given, 2 over 3 is given here, and we want to find cosine x. Now cosine x in quadrant 2 will be negative, so it will be negative, okay, 1 minus 2 over 3 squared. You use this again, like you will use cosine squared 1 minus sine squared. So you will use this one, and it will give you 5 over 3 squared, 5 over 3. Check, please, and you will end up with this. So the answer is now, I think the answer will be minus 4 square root 5 over 9. Yeah, please check this out. But yeah, and you can say here, hey, this is negative here, but this was x is in quadrant 2. Okay, it's okay because x quadrant 2 it's positive, but maybe it's double. 2 times x will be in quadrant 3 or quadrant 4. I mean, at least it will be in quadrant 4, I guess. So for this reason, it is normal to get a negative value here. Please do this problem and follow the same steps as